Hello, Prealgebra students. This is Lesson 16. In Lesson 16, the objective pretty much is what are irrational numbers. We're trying to understand what irrational numbers are. In order to understand what irrational numbers are, I'm going to ask you the question, what are rational numbers? Because kind of irrational means not rational. So then what is a rational number? Well, let's go back. We've already talked about that back in lesson before. So rational numbers are numbers, notice the word ratio at the beginning, that can be written as a ratio or as a fraction. So numbers like 1/3, 7/8, 4/2, or 2, right? That's like 2 over 1. And 3, because that's 3 over 1. 7,000, because that's 7,000 over 1, etc. Those are all what we call rational numbers. Even numbers like 3.456 can be written as a fraction as 3,450. That should be a 6 right there. Over 1,000. And numbers like 0.3333 repeating can be written as 1/3. These are all rational numbers. So if all of these numbers are rational numbers, in order to say it is irrational or not rational, it cannot be written as a fraction. So what number can we think of that cannot be written as a fraction? Because really, these are most of the numbers that we've ever dealt with since forever. So now we're talking about things that cannot be written as a fraction. And maybe if you think about it real hard, there are a few numbers that we've talked about so far that cannot be written as a fraction, and those will show up. Well, they'll show up right here. So just keep in mind that if a decimal, that's supposed to be decimal, repeats, meaning it has a pattern, or if it stops, so if we say it terminates, if it stops at any point, then it is rational. So that means to be irrational means it cannot ever repeat, meaning that it does not have a pattern to the numbers that show up in it. And also it does not stop, meaning that it goes on for forever, that these decimals are infinite in length and you can keep calculating a better and better and better and better approximation of these irrational numbers. Okay, so let's just take a glance at maybe what are some irrational numbers. Maybe the first one that you may have thought of is this one down here. Pi is an irrational number, and you got introduced that back probably in 3rd or 4th or 5th grade with dealing with circles. Pi is the ratio of the circumference going around the circle divided by the diameter of the circle, and it ends up with this really long number. And you can calculate it more and more accurately, but this is just what my iPhone will give me for an estimate of what pi is equal to. But again, notice if you look through these numbers, you can't really find a pattern. In fact, you cannot find a pattern. There is no pattern in these. And this number would actually keep going on for forever. Same idea with the square root of 2 or the square root of 3. There's no pattern in the numbers, and they would keep going on forever. You can keep finding something more accurate than this to approximate the square root of 2. E is another one that shows up in nature, is a really cool thing. So these are just examples of irrational numbers. Again, they do not stop, and they do not repeat. They do not have a pattern in them. And just for a quick note, this will be on a quiz or a test. Pi does not equal 3.14. Pi is approximately 3.14. That's why we have those little squiggly things. So I'm going to have to put like a true or false on there and say like pi is equal to this and it's going to be worth points. So make sure you understand that. Just a quick note here. We call real numbers is a set of numbers that are both rational and irrational. So if you see a number that is rational, then we say it is real. And if you see a number that is irrational, we also say it's real. So it's kind of a set of both of those together. And believe it or not, there are numbers that are not real, but that will come later in your math career. Fun stuff, though. Okay, let's do just a couple examples here. What you're going to be expected here in your homework to do But it just says, it's like example 1 says, what number is irrational? What number is irrational? So we have 4 different options here, which means 3 of them must be rational because only 1 of them can be irrational. So let's look at this. Well, the square root of 1 is saying what number times itself will give you 1. Well, 1 times itself will give you 1. This is just equal to 1, which if we wanted to, we could write it as 1 over 1, which we would recognize obviously as being a rational number. So it's not A. Let's look at B. It says the square root of 16. Well, what number times itself will give you 16? Well, 4 times itself will give you 16. So this number is just equal to 4, which if you again wanted to think about as 4 over 1, again, it can be written as a ratio. So nope, not that one. So not B. C, same idea. What number times itself gives you 100? Well, 10 times itself. 10 times 10 gives you 100, so that means this answer is going to be 10. Again, 10 is a rational number. So not C. Which leaves us, of course, then with D being the correct answer, because there's no number times itself that will give you 5 without doing some decimal approximation of that. So yeah, D is an irrational number. Alright, now let's look here at one like example 2. It just says arrange the real numbers from least to greatest. So let's look through these. Obviously, it looks like we have one that's a negative. Since we only have one number that's negative, it's going to have to be our smallest one. That's this one right here. So I'm going to say negative 3/4, negative 3/4. My next number would be a number that's not negative or positive. That's 0. So I'm going to put that one next. Alright, and then we're just looking through these last ones. So we've used this one. We've used this one. So now we have 1, 2, 3, 4 positive real numbers. Well, we know that 3 is going to be bigger than 2. And we know that 2 is going to be bigger than 1.1. But what is the square root of 2? Well, we could use our calculator to approximate that, but really what we're trying to find out is 2 bigger than 1.1? And if so, is it smaller than 2? So let's just real quick, what is 1.1 times 1.1? That would be like saying 1.1 squared. That would be, I'm just thinking of 11 times 11. So it's going to be 1.21, correct? So the square root of 1.21 would equal to 1.1. Follow that thought process, I hope. So then, this, since 2 is bigger than 1.21, the square root of 2 is going to be bigger than that. The square root of 2 is going to be bigger than 1.1. So then my next number is going to be 1.1. If I took 2 and squared it, I'd get 4. So then, right, 2 times 2 is 4. So square root of 4 is equal to 2. So that means this number, the square root of 4, which is the same thing as 2, is going to be bigger than this number. So the next number on my line up here would be the square root of 2. Then 2, then 3. Just to check to make sure I have 1, 2, 3, 4, 5, 6 numbers. I start off with 1, 2, 3, 4, 5, 6 numbers. Excellent. So then my answer is going to be in that order. In case you haven't noticed it down here at the bottom yet, your homework is going to be on page 105. All of them from lesson 16, all of them from lesson 15, and then 12 more of your choice. Good luck. I know you're going to do great.